In this video, we're going to look at transformations of graphs and their rules. So we're going to use a general curve as fx. Now fx can be any function, but I'm just going to draw a function like this and call this y equals fx, a general function. So the first rule of transformations of graphs is when we have something like this. If they say to sketch the graph of f of x minus 3. Now the rule is if the number is inside the bracket, we always do the opposite of this number, provided the number is in the bracket, and we move it on the x-axis. So we do the opposite and move along the x-axis. That's the rule. So I'm going to sketch this now. So it moves 3 squares towards the right. So it's 1, 2, and 3. So I'm going to move it along 3. 3 units towards the right hand side. So likewise, if I wanted to sketch fx plus 5, then I would do the opposite of plus 5, which is minus 5, and go 1, 2, 3, 4, and 5 units towards the left, the opposite of what has been described, because it's in brackets. Here's a question for you to try. You can pause the video. When you're done, I will go through my work solution. Okay, welcome back. So this question says to sketch the graph of, first of all, fx minus 5. So we know the rule for this is in brackets. So we do the opposite of minus 5, which is plus 5. So I go 1, 2, 3, 4, and 5. Next one, fx plus 6. We do the opposite. So we go to minus 6. So 1, 2, 3, 4, 5, and 6. So call that minus 6, and we draw a sketch. So you should get a graph sketched like that. The next question says to draw the graph of y equals fx plus 5. So if the number's not in the bracket, we do exactly what it says along the y-axis. So we move along the y-axis by what it says, by plus 5. So we're going to go up by 5 squares. So 1, 2, 3, 4, and 5. And then we can draw our graph. So that's how the graph will look. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we want to draw the graph of y equals fx minus 3. So don't forget, we move the graph down along the y-axis by minus 3. So I'm going to mark it minus 3 here. And just draw in our graph like this. So that's our graph. Fx minus 3. The next rule of transformations of graphs is the following. We want to draw the graph of y equals to minus fx when the minus is the outside. When the minus is on the outside, the rule is you reflect the graph in the x-axis. So your x-axis is your mirror line. So here's my mirror line. So I can draw this graph here, and this will be its reflection. So this will be the graph y equals minus fx. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we've got our graph here. We want to sketch the graph y equals minus fx. Don't forget the rule for this is that you reflect the graph in the x-axis. So let's write that down. Reflect the graph in the x-axis. It's only a rough sketch, so we can do that here. So that's what we get for our graph. Coming down. So that's going to be the graph y equals minus fx. In this next example, I'm going to show you how to draw the graph of y equals to f of bracket of minus x, when minus x is in the bracket. The rule for this is that we reflect fx, or the original graph, this time in the y-axis. Don't forget, this graph is a sketch, it hasn't been drawn to scale. So we treat the y-axis as the mirror line, and we can draw it here, and we can say at this point is the reflection of this in the y-axis. So we can see the only thing that's changed is the x-coordinate. So instead of 6, it will now become minus 6, and the y-coordinate is unchanged, which is 3. And that will be the graph of y equals f of minus x. Okay, here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So don't forget, it's only a rough sketch. So we're going to draw a reflection in the y-axis, and we can say that the x-coordinate will now go from 5 to minus 5, and the y-coordinate is unchanged, and that is the graph of y equals f of minus x. Next example we're going to look at is when we have a case like this. Y equals, say, a third of fx. So what we're going to do for a question like this is say, well, it's outside the bracket, so we do multiply the y coordinates. So we're going to multiply the y coordinates by a third. So in our case, we're going to do 9 times a third, which is 3. So the maximum point now on the graph will now be 3 instead of 9. So we sketched that, it goes through the same x coordinates. So as in minus 3 and 3. But now this is now going to be 3. And this will be the graph of y equals a third of fx. Remember, only the y coordinates are affected. Now the other case we're going to look at is y equals f of a third of x. Now don't forget, now it's inside the bracket, so it affects the x coordinates. So instead of dividing by 3, we're going to multiply. So we're going to say multiply x coordinates by 3. So in our case, minus 3 and 3 will be multiplied by 3 to give me minus 9 and 9. So now when we draw a new graph, this will now be minus 9 and 9, and this is the point 9 on the graph, and this will be the graph of f of a third of x. Okay, here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, so we've got a function now that cuts the x-axis at minus 4 and 4. It crosses the y-axis at 16. And we want to draw the graph, first of all, of y equals 2 times fx. Well, we know how to do that. So we know that if y equals to 2 times fx, the y coordinates get multiplied by 2. So we can go back to our graph here, and say, well, the y coordinate is 16, so I'm going to double that, so I get 32. So it's going to be a slightly longer graph. So write 32 here, but the x coordinates remain the same, -4 and 4. Now the next part of the question says, now draw the graph of y equals f of a half of x in brackets. Now that you got that, we know what the rule is for this. This is inside the bracket, so we multiply the x coordinates by 2. So if we go back to our original graph, so we've got -4 and 4 on the x-axis. So we're going to double that. So this will now become -8 and 8, and this will still remain at 16.